Hello everyone. So we have got this JE main relevant question on the chapter of equilibrium. So let's just go through this question once and see what it has to offer. So an equation has been given and we have been asked to find the relationship between alpha and the pressure. Okay. Okay. At pressure P. Okay. So and the equilibrium constant has also been given, which is Kp. So let's start this question. Let's first write the equation here. A very popular equation, that is N2O4. It dissociates into 2NO2. Okay. So let the initial pressure be P naught. Okay. Uh, Initially, this is zero, right? Because there is no NO2 existing in the container uh, previously, right? So N2, the only thing that exists is N2O4, and let the pressure be P naught. So after some time, as it dissociates, this will be the concentration or the pressure, I would say, of N2O4. And since there are two moles, by the way, PV equal to nRT, right? Volume is constant, okay, and R and T is also constant. So P is proportional to N. So that is how I'm doing this. This is actually the formula for moles. Okay, like this is actually the relationship which we do for moles, but we can also apply this for pressure because P is proportional to N because everything else is constant. Okay, so now it has been given that at equilibrium, the pressure of the entire container will be P, right? Yeah. So basically, P naught minus P naught alpha plus 2 P naught alpha is equal to P. Okay. And therefore, P naught 1 plus alpha is equal to P. And therefore, the initial pressure, P naught is equal to P divided by 1 plus alpha. P divided by 1 plus alpha. Okay. Now, Kp has also been given. We will find that out very easily. The value of Kp is basically P product to the power of the coefficient divided by P reactant to the power coefficient of the reactant, right? The number of moles of reactants which are present. Anyways, so this will be uh, 2 P naught alpha whole square divided by P naught 1 minus alpha. Okay. So this will be 4 P naught square alpha square divided by P naught 1 minus alpha. So let's cancel the P naught. Now we will put the value of P naught in terms of P because that is what we have to find, right? P has been given, not P naught. So this will be uh, P divided by 1 plus alpha, alpha square 1 minus alpha. Okay. So this will basically be 4 P alpha square by 1 minus alpha square. This is equal to Kp, right? Now, if we have a look at the options, we have to find alpha. Okay. So we have to find alpha. So let's just cross multiply. Kp minus Kp alpha square is equal to 4 P alpha square, right? So in order to find alpha, let's just do this very basic calculation. So alpha is equal to, or rather alpha square is equal to Kp by 4P plus Kp. Okay. and therefore alpha is equal to root. Now let's do one thing. Let's divide the numerator and denominator with p, because that is the form in which the options have been given, ap by p. So there you have it. This is the answer to your question. Okay, option number C. Also, uh, this particular question, see N2O4, right? This is a very, very important structure for the chapter of chemical bonding. Not just N2O4, but also N2O5, N2O3 as well, okay, and NO2 as well, okay. Remember the property, one very special property of N2O3 is that it is blue in color. Okay, this is a very, very common question for mains, and these are just some facts which you have to remember, and you can score 4 marks very easily. Okay, thank you.